Good day to teacher Amin and all my fellow friends. Today, my teammate and me are going to present for MTES3232 Task 1, which is presentation. So my name is LEARNINGTHEORIES and her name is Evnice. Both of us are come from Maths 2. So for our presentation, we are going to teach about the topic which is coordinates for year 4, and it is based on KSSR Mathematics Year 4 textbook. So it is in the learning area of coordinates, ratio and proportion. In this topic, students will learn to locate and represent positions using ordered pairs XY on a Cartesian plan. So after learning the coordinate, they will understand the coordinates, develop spatial reasoning and logical thinking. So for our activity, the title is Coordinate Messenger, Draw and Guess Challenge. So our learning is focused on understanding and plotting ordered pairs in the Cartesian plan. So the activity is in pair work, which means that we will separate the student into student A and student B. So student A will be the messenger, which is draws and give coordinate, while student B will be the plotter, who will plots and connects the points, and student B need to guess for the picture. So in this activity, what are the materials that are needed? So we need the printed Cartesian plan, which is 15 times 15 grid. And we also need the pencils and erasers and also ruler. And we will give the student to look the simple straight line pictures such as house, car, boat and fish. And last, we have to need a timer because we have the setting time for the student to do the challenge. And these are all the example pictures that we will be given to the students to draw on the Cartesian plan. So, what is the procedure of this activity? The first step is that we need to do for the preparation and pair students. So, before the activity starts, we have to explain the coordinate and ask questions to the students in order to make sure that they understand the concept. And we also have to give them the guidance and supportance. After that, we can start the activity by pairing the students first. So we have to pair the student A, become the drawer, and the student B as the plotter. For the next step, which is drawing phase, student A will be given to look a picture, and he or she need to redraw the picture on the printed Cartesian plan. And student A need to identify and write down all the coordinate lists in 3 minutes given. Later, we will give student A 3 minutes to adjust his draft. And the third step, which is coordinate communication. So in 5 minutes given, student A will read aloud the coordinates list, and student B have to plot the coordinate without seeing the picture. So after plotting, student B need to connect the points in order. After that is the guessing phase. So student B need to look at the completed drawing and need to guess for the picture with 2 chances. So if correct, both student A and student B will earn 1 point. If wrong, they will not get any points. And for the fifth step, which is change the role. So student A and student B need to change their role and continue to play this activity for the second round. So they need to repeat the steps 2 to step 4. And last, we will have a reflection discussion with the students A and student B. So we will ask them, what have you all learned today and what happened if you change one coordinate? So if they're correct, means that they are already understand what we are teaching today and they already have known what have they learned about the concept of coordinate.
Good morning, class.
Good morning, class.
Good morning, teacher.
Alright, so today we are going to talk about the coordinate, ratio, and proportion. So first of all, we will today's main point is about the coordinate. So the paper in front of you are the Cartesian plan. Yes. And got 15 numbers, which is 0 to 15. So in this iPad, we can see that there's a dot plot on this plan. So what do you think the value of this dot? What is the value? Okay, why?
Because normally coordinate we need to write in the form bracket x, comma and y. But when we read out, we need to read x, y. So when we see the dot, we need to see for the x-axis first, which is the below one. So what number here? 3. And then after we look the x-axis, we have to look for the y-axis, which is beside here. So what is the number beside here? 4. So the answer is
3, 4.
yes. So now you all understand already about the coordinate.
Yes.
So let us practice some questions. So plot 4x on the paper.
Oh, well done, my dear students. So give a big clap for yourself. So now we are going to play again to help you to understand more about the coordinate and can get the concept.
So the game is coordinate messenger draw and guess challenge, which has been written on the paper. And for the rules, we need to do it in pairs. So we will have student A and student B. So who wants to be the student A first? Me. Okay, so later we will give student A to see a picture, and student A will draw the picture into this direction plan. And then you need to analyze what is the coordinate, and you need to write in the column here. After that, you have to tell the coordinate list to student B, and she will plot it on the partition plan again, and she needs to guess what the picture is. Okay, understand the rule already?
Yes.
Okay, so now I'm going to show the picture that should be drawn by student A.
Student B is not so high.
This is the example of the picture that we will show to student A. Yes.
No problem, teacher.
Okay, good. So, let it for 1 minute and I give you another 2 minutes to play. Okay? Thank you.
Okay, no problem. Okay, so latest plan is going to tell the student B about this coordinate list. Okay. Student B, please be prepared. Both of you will be given 5 minutes only. You tell her the list and she need to draw. 5 minutes only.
Can you guess out what are you?
We will switch the role. You become the student A and you become the student B.
Okay, so student B, please face towards the wall. Okay. Now, this is the picture that this round picture I have to draw.
Okay, so now student B is prepared. Okay. Given 5 minutes and 3, 2, 1, start.
2, 3. 3, 1. 4, 3. 4, 5.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122
our reflection today. So, students, what have you learned today?
Coordinate.
Specific, x-axis and y-axis. Yes. So, what does the point of the coordinate form from?
X
And
Y.
yes.
We need to
do x-axis first or y-axis first?
X.
Okay. So how do you write the coordinate? How do you write? X, Y. Yes. So clever. Okay. Big class. Okay. So now we have a question for you. What if the picture here, if one of the coordinate change, what is the result or the effect?
We cannot know what's our premise goal.
Yes. For example, like this, triangle maybe can become square.
Yes.
Okay. Seems like you all already know what is coordinate and the concept already. So that's all for our class today.
Thank you, teacher.
Thank you. Bye-bye.
Bye.
So in this activity, we have applied two learning theories. So for the first learning theories is Bruner's learning theory. So Jerome Bruner's learning theory is a cognitive and developmental theory that suggests students construct knowledge by actively engaging with material in the activity. According to Bruner, learning is not passive absorption of facts. Instead, students need to process new ideas by building on prior knowledge and progressing through structured stages of representation. This theory is usually widely applied in education, including mathematics learning to support deeper understanding and active learning among the students. So, usually Bruner's learning theory include three modes of representation, which is enactive, iconic, and symbolic. So there are a few key principles of Bruner learning theory relevant to the mathematics learning. So the first one is active discovery. So Bruner emphasized that students learn best when they discover the concepts by themselves rather than receiving direct instruction from teachers. In mathematics, this means that students have to explore the patterns, solve problems through guided tasks, and focus on understanding instead of memorization. So in result, their learning will become more meaningful when they are actively involved in constructing knowledge. The second principle is the three modes of representation, which I mentioned before. It has the learning progresses through three stages, which is enactive, iconic, and symbolic. So, enactive refers to learning through actions and hands-on activities, such as playing blocks or counters. Iconic refers to learning through visual representations, such as diagrams or graphs. And for symbolic, it refers to learning through abstract symbols like numbers and questions. This progression can help students to move from concrete understanding to abstract thinking in their learning. And for the third key principle, which is scaffolding and structure learning, Bruner proposed that teachers should provide structured guidance at the beginning of learning. So the support will be gradually reduced for the students because at last the student will gain confidence slowly and competence also. And this can help to build their independence and strengthens their problem-solving skills in their learning. And for the last key principle, which is connecting to prior knowledge, new concepts should be linked to students' existing understanding. When students connect new knowledge with what they already know, they will build deeper conceptual understanding in themselves. So in conclusion, these principles emphasize active learning, structured guidance, and progressive development from concrete to abstract thinking in mathematics education. Now I will explain how the coordinate messenger activity aligns with Bruner's learning theory. So this activity strongly reflects Bruner's key principles, including active discovery learning, modes of representation, scaffolding, and building on prior knowledge. So for the first one, active learning and discovery, Bruner emphasized that students construct knowledge through active exploration rather than passive listening. In this activity, student A need to design and communicate for the coordinate points, while student B need to plot the coordinates and discover the hidden picture. So, as we know, student B is not told what the picture is. So their understanding develops naturally through plotting, observing patterns, and analyzing the ordered pairs. And this can reflect Bruner's idea of discovery learning, where meaning is constructed through engagement and problem solving. The second one, which is three modes of representation, which also mean concrete to abstract representation. So we already know that Bruner proposed three modes of representation, which is enactive, iconic, and symbolic. So in this activity, students draw and physically plot points, so it refers to enactive learning. And for iconic, student B visualize the emerging shape while connecting the plotted points. And for symbolic, they have written the ordered pairs x, y, and this can represent position abstractly on the Cartesian plane. So the progression from drawing a concrete picture to interpreting symbolic coordinate notation has mirrored the Bruner's movement from concrete experiences to abstract mathematical thinking. The third one is scaffolding and guided learning. So Bruner also emphasized that structured guidance before independent learning. So in the activity, we first explain coordinates concept, then ask the student to practice basic plotting skills with guidance. So after that, students will independently perform the guessing challenge, and the support will be reduced as students already gain confidence from the supportance from the teachers. So this reflects Bruner's concept of scaffolding, where assistance is provided initially and then withdrawn progressively. And for the last one is building on prior knowledge. So before this activity, students already know the ordered pairs, number sequencing, and also the basic plotting skills. And later, this activity will extend those existing skills into a new context, which promotes deeper conceptual understanding rather than rote practices. So in conclusion, the coordinate messenger activity aligns closely with Bruner's learning theory because it promotes active discovery, integrates concrete to abstract representation, provides scaffolding, and builds on prior knowledge. Therefore, Bruner's theory really helps in designing an interactive and concept-based coordinate lesson. So now I'm going to explain why Bruner's learning theory is suitable for this lesson. So first, Year 4 students learn best through active involvement, not passive listening and repetitive practice. At this age, students need to engage, explore, and interact with the learning material. So this coordinate activity allows them to actively participate rather than just copy the answer or doing the practices. Second, the activity encourages discovery learning. So students can construct understanding by plotting and analyzing the ordered pairs. When student B plots the coordinate, they can discover the hidden picture on their own. The teacher does not directly tell them the answer. Instead, understanding develops naturally through exploration and reasoning. This really reflects Bruner's idea that learning happens through discovery. And the last one, the activity progresses through Bruner's three modes of representation. It begins with enactive learning when students draw and plot the points. It moves to iconic learning when students visualize the emerging image. And finally, it reaches to symbolic learning when students work with abstract coordinate notation such as x, y. This progression from concrete action to abstract representation supports deeper learning and mathematical thinking. Therefore, Bruner's theory is suitable because it promotes active engagement, discovery learning, and a structured movement from concrete to abstract understanding. This makes the coordinate lesson become more meaningful and make the Year 4 students can easily gain their knowledge about this topic.
So now I'm talking about the learning theory 2, which is constructivist learning theory. So it is a student-centered plan, and students are learning through the experience, reflection, or the interaction with others. Students also actively build their own understanding by connecting the new information with which they have already learned instead of just receiving the information from the teacher. There are 5 key principles of constructivism which are relevant to mathematics learning. So the 5 principles are active construction of knowledge, prior knowledge shapes learning, social interaction facilitates learning, the problem solving and meaningful tasks, and the last one, learner-centered approach. For the first one is active construction of knowledge. So students interpret the new mathematical ideas by relating them to what they have already known. So this active mental process will make them understand the concept deeper. So for example, in maths class, this looked like the students exploring patterns, experimenting with the problems, or discovering properties instead of just listening to the teacher's explanation. So the second one is the prior knowledge shapes learning. The students using their existing knowledge and experiences as the foundation for learning the new math concepts. In this process, if the new information doesn't fit the old one, the student will have to adjust the mental frameworks, which is the schema. For example, before learning algebra, the students connect to the understanding of arithmetic operation. The third one is social interaction facilitates learning. So in this case, students need to collaborate and discuss the ideas. The classmates need to help each other to study and ideas or share their ideas, explain their thinking, and refine their understanding. So this math learning can involve group problem solving, peer explanation, and class discussion to make students join the learning process actively. The fourth one is problem solving and meaningful tasks. So students will feel satisfied and happy when they have solved a real problems or an open-ended question that will require them to think critically but not memorization. So this process will encourage the critical thinking and help students to see the why, which is the reason behind why the mathematical concept is formed. The fifth one is learner-centered approach. So this will focus from teachers explaining to the students constructing understanding. So the students will actively join into the learning process, but the teachers will just act like a guide or facilitator who supports them for each exploration. So next we're talking about the alignment with constructivist learning theory of our activities conducted. So the first one is learners actively build their own understanding. In this activity, student A observes and interprets the picture, then they will need to record the coordinates based on their own understanding of the point. So this is an active process. The students are not given the answer, but they have to work it out by themselves. The second one is social interaction will support the understanding. In this activity, student A need to communicate the coordinate with student B. Meanwhile, student B need to listen, interpret, and draw based on what has been communicated by student A.
So last, together they will check and correct the understanding of the coordinate system. For the third one is learners connect new ideas to prior knowledge. So in this activity, students must recall and apply the previous knowledge of the concepts that they have learned. So this can deepen the understanding through application of the concepts in this activity. The fourth one is the task is meaningful and contextual. So in this activity, it involves interpreting a real task, which is communication and the drawing. So students will see why coordinates matter, but not just know how to write them. For the fifth one, students reflect and adjust their understanding. So in this activity, students can compare the final drawing with the original one and reflect on the mistakes. For example, like the misplaced point or the wrong coordinates. So then they can revise the understanding accordingly. So this is an important constructivist process for them. But why constructivist learning theory is suitable for this lesson? So for Year 4 students, they can build their own knowledge through the experience and active engagement instead of passively receiving information from the teachers. Also, they can link the new mathematical ideas like plotting a point or understand the coordinate to what they have already learned about the number and the coordinate grid of the first quadrant of Cartesian plane. The next one is the activities where students have to work together, discuss ideas, and solve problems. So this will develop their math skill and also the communicating and teamwork. The third one is this task is constructivist and it involves the group activities and drawing. So based on the coordinate, it will make learning hands-on and enjoyable. Last, when students explore, test ideas and solve problems themselves, they'll develop a higher order thinking skills such as reasoning, analyzing, and reflecting. So this will help them in the future of learning their mathematics. So now we're talking about the learning outcome. The first learning outcome will be involve learning standard. So based on the DSKP of Mathematics Year 4, pupils should able to recognize the x-axis, y-axis, and the origin of the Cartesian plane. And pupils should be able to determine the coordinates of a point in the first quadrant and vice versa, which including writing coordinates in the form of x, y. The next that is included is skill development. So there are two skills that students will develop, which are logical thinking and communication and collaboration. So in logical thinking, these mathematical tasks that require decision making, multiple representation, and the problem solving will strengthen the higher order thinking skill, including logical reasoning and strategic thinking. And for the communication and collaboration, so the classroom approaches that integrate communication and collaboration will support the development of mathematical thinking and expression. These are vital for explaining coordinate position and working with their peers during the pair activities or their group activities. The next one is engagement. So there are two parts in this, which are the game-based interaction and engagement, and another one, active participation and curiosity. So in game-based interaction, the students will be motivated and feel interested, which support the active participation and deeper involvement in problem solving. of the students. So the next is the active participation and curiosity. So these tasks involve challenge, exploration, and interaction aligned with the modern educational practices will emphasize the learning through doing by hand and discovery, which help to sustain curiosity and involvement in mathematics.
So now I'm going to talk about the pedagogical quality and reflection about this activity. So what is the strengths of the activity that you chosen for the coordinate? So the first one, student-centered and interactive. The activity, which is the coordinate messenger, is really actively engage students in plotting and connecting the coordinate points rather than passively receiving instruction. Students can explore patterns through hands-on manipulation, which promotes meaningful mathematical learning in themselves. For the second one, conceptual understanding. So through discovery, instead of memorizing procedures, students discover how ordered pairs determine position on a grid. This can help to strengthen their conceptual understanding of the relationship between x and y values. And the third one is practical and curriculum aligned. So this activity aligns with the KSSR mathematics curriculum for coordinate and reflects the authentic classroom practice that's suitable for primary students. And the last one, which is minimal resources required. Only grid paper, coordinate worksheets, and simple drawing tools are needed for this activity. So this really make it feasible for real classroom implementation. And for the last one, which is age appropriate, so this activity is very easy to be done, and for year 4 students, it is very appropriate for them to play this activity since they can easily gain the knowledge from this activity. So despite the strength, we have also anticipate a few of challenges in this activity. So for the first one, confusion between x, y or the pace. So some students might get confused with x, y coordinate at first, and this will affect them in this activity if they have misunderstanding or misconception. And the second one, cognitive load and task complexity. So if there are too many coordinate points are introduced at once, students may be experience difficulty processing instruction and maintaining accuracy. So the next challenges is that time management. So time management could be tricky if one of the students do its parts out of time. And the next one, variation in students' ability levels. So mixed ability students may progress at different speeds, affecting pair collaboration and overall task completion time. So to overcome these challenges, we can, as teacher, we can provide visual reminders like a coordinate poster or label access, and also we can also demonstrate the plotting first before the activity or the class start. So we can have a quick guided example to reduce the confusion among the students so that more they can have more understanding about the topic and about the concept. And the third one, gradual increase in difficulty. So maybe we can try to begin with simple coordinate patterns before introducing to the more complex images so that it can help to manage the cognitive load among the student. And last one, differentiated worksheets. So we can also try to prepare different multiple levels of worksheets. For example, start from basic to intermediate and last to the advanced so that it can help to accommodate the diverse learning abilities among our students.
So last but not least, we come to our conclusion. So from the constructivist learning theory, where explains that students may build their own understanding through their active experiences and connect the new ideas to the what they have already learned. So these coordinate activities will fit this approach because students can explore, can communicate, and make sense of the coordinate through doing and interaction with others. Also, the Brunner learning theory support this by emphasizing the discovery learning, which students will learn best when they find out the concept by themselves and link the new knowledge to the prior experience. So regarding to these two learning theories, teachers may guide the students with scaffolding and make some game-based activity to make the lessons more interacting, and the learning can build progressively.